All right, let's talk about some other audio hardware beyond microphones. I think we've had enough of those for a while. So there's quite a bit of other gear. I'm just going to give you some of the stuff that you really do need to know for working in the studio and at home. We'll start with microphone preamps, which their sole purpose is to take the small electrical signal coming out of a mic and boost that up to line level so it can be easily sent to a console or other gear that you're going to actually use to record. Now they are typically built into consoles or interface, but typically they're only okay. Some are really nice and super transparent. Others are kind of, we found this part on the floor and decided to throw it into the machine. Anyway, that's why you have a lot of people who still make preamps exclusively. Each preamp has its own sound and characteristics, which is why they can get really expensive if you're paying for a specific sound, like, say, the Neve or API preamps, or if you want something super, super clean. It's also why units that are not integrated into your audio interface tend to sound better. Separate preamps are almost always going to be cleaner and clearer with a better frequency response. Typically, they are going to come in 1 or 2 channel versions, although if you're willing to pay, you can get them in up to 8 or more channels in a single unit. Some are going to be tube-based and some are solid state. Tube-based preamps do sound warmer, but they're more expensive. Solid state, however, is much more consistent, reliable, especially if you're recording outside, because unlike tubes, they're not going to be really sensitive to temperature and humidity changes. So in order to boost a signal to line level, you're going to have a couple of options on the preamp. Basic things like gain control. What's the amount of the mic signal that's amplified? Usually around 60 dB of amplification, but some may have more to accommodate really quiet vintage mics. There's usually some sort of meter or visual indicator that lets you see if the mic is overloading the circuit and clipping. Typically, it could be a red dot or it could be a needle. There will usually be a pad or attenuator, which is a switch that usually cuts off 10 dB, although you'll see more or less depending on the manufacturer, from the mic signal so that it can handle louder signals without clipping. Phase control is the next thing you'll see. This changes the polarity of the mic signal to compensate for acoustic phasing, or more usually bad placement or bad wiring, by swapping 2 of the pins in the XLR. You'll also see high-pass filters. These are really, really useful because they will apply a high pass and get rid of all the frequencies below usually 40 to 60 hertz, although some will go as high as 80 to 100. This gets rid of hum from ground isolation loops, gets rid of weird low-frequency ambient noises that might be in the room. It's just a really, really nice thing if you're not going to be recording at those frequencies to get rid of them. Then there's going to be an output to the next part of your signal chain. Here's an example. This is an API 512C. You can see it's got a gain. It has a polarity switch, which is the yellow button, plus phantom power, 48 volts, a negative 20 dB pad. Like I said, they can be more than 10. And it's got a mic or high Z input switch as well. So you could use this with a guitar. Then on the right to the side of the gain, you have a VU meter showing the level of the sound. Next piece of thing to really consider is signals and cables. Different devices transmit different types of signals. You need to know what they are, and you need to know what cable carries them. So, what are they? Some are going to overlap, but most are going to be one type of signal per cable. For example, mic signals. Balanced XLR cables. So the balanced part means that the cable is sending 2 copies of the signal with a ground as well. This helps to eliminate noise over longer cable runs that would be picked up by the cable if it's not shielded, but you still have, only so far that you can go. without having a preamp somewhere in the chain, I don't recommend going over at the most 50 feet of cable. That's about my limit, and that's even with a preamp. Line level signals are output by synths, most audio processing gear, and the output of your mic pre's. These are going to be a higher, hotter signal level than mics. There are two versions of these. There is the Pro, which is plus 4 dB, and uses a balanced TRS cable, that's tip, ring, and sleeve. Then there is the consumer level, which is negative 10 dB. That uses an unbalanced TS cable, or worse yet, it uses the 3.5 millimeter or RCA cable. So what's the difference between balanced and unbalanced quarter-inch cables? Having that ring there. That means that they have two conductors sending two copies of the signal and a ground. If you have a TS cable, you have one copy of the signal and a ground. That is really important because, again, similar to the mics, you can then get longer runs and you've got the elimination of noise in there. Instrument signals is the next type. These are typically the output of an electric guitar or electric bass. These are the high Z or high impedance signals, which means that the signal is really weak on its own and it needs some boost. This is what you have to crank up to 11. Typically, this is the high Z inputs on an interface, on a mixer, on a preamp, or if you don't have that, get a DI box, because they will take that into their input, boost it like crazy, raise it to line level of a mic signal, and then send it out. These are always going to be a TS cable. So DI boxes, which you can see over on the right, raise the high Z signal to the level of the mic signal. They bypass the need for a mic and any possible bleed because you just have the TS in and an XLR out. They also help with longer cable runs because you can get powered DI boxes that will give it just a little bit more of a boost. Very useful. And DI boxes that have built-in things like tubes, or if they have just slight filters or EQ, can actually make synths sound better. All right, other cables. Let's talk about speaker cables. So the output from a powered amp going to a passive speaker, not an active speaker. These are going to be really high voltage and high power. They will definitely cause damage to other devices. This is what you're plugging in on your home stereo speakers. Either raw copper cable where you just have to strip some plastic off of it and then plug it into the back of the speaker, or banana plug. Be aware that banana plug is also the standard used on the Buchla modular synth. Do not plug those into the back of your stereo. You will blow something up. Digital signals, we've got two major types that are used in the prosumer level. SPDIF, which is consumer grade. It looks like an RCA, but it is a digital cable. And then Toslink, which you can see at the bottom, which is a fiber optic version of SPDIF, but is generally going to be a slightly better quality digital cable. For pro grade, you have AES EBU, also known as AES3. It looks nearly identical to an XLR cable, but on a lot of manufacturers, they will make the AES cable blue and not black. Also, be sure to look at the label printed on the cables. Most XLR cables will say XLR. Most AES cables will say AES. Be very aware of that. Next thing is the audio interface. This is what converts analog to digital and digital to analog and puts it all on your computer or takes it off your computer. As a rule, never use the built-in sound card in your computer. They are awful, particularly in laptops where you have built-in speakers, and especially in Windows where you're using those Realtek audio cards that are built into just about every motherboard. They're horrible. Generally speaking, you pay what you get what you pay for. Higher cost is better, higher sample rate, larger bit depth, and nowadays on things like Universal Audio or Antelope Audio, built-in digital effects can be offloaded to the sound interface and not take up CPU cycles. Typically, audio interfaces will have 2 or more inputs: XLR, TS, High-Z, combo jacks, all of that stuff. They will have gain knobs for each channel and a phantom power switch, usually for a group or on the better ones for individual channels. They will have pad switches to reduce the input level for a channel or a group. Analog outputs, typically these will be TRS or TS. Headphone outs with a separate gain knob, so you're not tied into your master knob. Most will have digital I/O of some type. You'll typically see SPDIF or Toslink. Rarely, but not unheard of, you will see MADI, which is a fiber optic cable that allows for up to 1 mile of cable runs. It's very cool. You will also see MIDI inputs and outputs, very commonly. And then some sort of computer connection. USB, Thunderbolt, Pro Tools HDX, FireWire, or PCI via a breakout box are all common, although FireWire, of course, is being depreciated, and there are fewer and fewer dedicated PCI breakouts anymore as well. Here's a picture. This is the Focusrite Scarlett 2i2 that you will probably remember from the lab. You have 2 inputs, each of which has a separate gain knob. They do show the signal level in the LEDs that are around that knob. I'm not a great fan of that particular way of showing it, but okay. Then you have plus 48 volts, direct monitoring on and off, the monitor knob, which lets you blend between what you're hearing going into the interface and what you're hearing coming from the DAW. And then they have a separate headphone out and headphone control. Next is portable recorders. These are really, really useful for recording locations, getting individual sounds, recording things for film, for Foley effects, for video game sounds. Typically, these are going to have a pair of stereo mics built in, but the better quality ones will have XLR or combo jacks and can provide phantom power via those ports. The best quality ones are going to have really transparent preamps and built-in mixers. So the Zoom F-Series, like the F8, or anything from Sound Devices. All of these are going to have headphone outs for monitoring, which is essential when you are recording with a portable recorder. And you can set the sample rate, bit depth, and file formats on all of these, but which ones are supported will vary based on the manufacturer and cost. Almost all of them will do CD quality, DVD quality, and some will even go higher than that. Most will also allow you to record as MP3, but I really don't recommend doing that. Just go for at least CD quality. Here's a picture of the classic Zoom H6. This one you can see it has 2 built-in mic capsules at the top. It has 4 additional XLR TS combo jacks on the sides, and you can select all 6 of those to record at one time. Finally, we have amps and speakers. Speakers work in the same way that a dynamic mic works, just in reverse. It's a magnet inside of an electromagnetic coil that vibrates and transfers energy to the speaker cone instead of a diaphragm having the sound waves hit it and move the coil. So this combination of magnet, coil, and cone is called the driver. Now, there are ranges of speakers depending on what frequency you're reproducing. The subwoofer is your lows, your Barry White and below range. This is primarily sounds that you're going to feel, not necessarily hear. The woofer is your low range. The mid-range is your mids, and the tweeter is your highs. Amplifiers are what are used to boost a signal for a passive set of monitors. Passive meaning they aren't powered. Active monitors would be ones that have plugs, plug into your household current, and do not require an amplifier. But that's just a little bit of the common gear that we'll be using throughout the degree program. Just stuff you should know, and make sure that you have a good idea of what it does when we start using it.